So good morning. We will discuss about the Module 10, Electrochemistry and Nuclear Chemistry. Electrochemistry, redox reaction, more technically termed as oxidation reduction reactions, are reactions that result from the direct transfer of electron from one species, this is the reducing agent, to another oxidizing agent. Parameters of a redox reaction. During a redox reaction, two processes take place: oxidation and reduction. The species that will undergo oxidation is reducing agent, while the species that will undergo reduction is the oxidizing agent. So we have here the rules for identifying oxidation states. Number one, the oxidation states of an individual atom is 0. Number 2, the total oxidation state of all atoms in a neutral species is 0, and in an ion is equal to the ion charge. Number 3, group 1 metals have an oxidation state of positive 1, and group 2 an oxidation state of positive 2. Number 4, the oxidation state of fluorine is -1 in compounds. Number 5, hydrogen generally has an oxidation state of positive in compounds. Oxygen, number 6, generally has an oxidation of -2 in compounds. Number 7, in binary metal compounds, group 17 elements have an oxidation state of -1. Group 16 elements of -2, and group 15 elements of -3. Galvanic cell. Galvanic cells are electrochemical cells that facilitate spontaneous redox reactions in which the half reactions, the oxidation and reduction half reactions, are confined in separate electrodes, parts of galvanic cell. The conducting wire, so it will that connects the two electrodes. This is where the electron release by reducing agent flow. So this is the example. So this is the conducting wire. This is the electrodes. So you can see this is the electrolytes. This is the salt bridge. So this is the example of galvanic cell. So electrodes. So the electrodes R and electrodes S. So electrodes, cathode contains the reducing agent, where it is dissolved in the catalyte solution in the electrode upon oxidation, while anode contains the oxidizing agent, where it is deposited from the anolyte solution to the anode plate, usually made up of the reduced from the oxidizing agent. Salt bridge. So in salt bridge, this is the one. Okay? Salt bridge that connects the two electrodes to form a closed circuit. It contains a solution containing a salt solute to neutralize the charge built up in the electrodes. The anion goes to the anode, while the caution goes to the cathode. Voltmeter. So voltmeter, it is which detects the potential difference between the electrodes. For a galvanic cell, the cell potential should always be positive. So this is the example of voltmeter. So in voltmeter, yung gauge niya, tataas yan kapag ano na siya sa positive at saka sa negative charge. Okay? Standard reduction potential are potentials of different reduction half reactions in chemical literature. These values can help determine the degree of completion of a particular redox reaction, as well as its spontaneity. As the reduction potential increases, the strength of the oxidizing agent increases. For galvanic cells, the electrode containing the species with a higher reduction potential is usually the cathode. The other one acts as the anode and therefore undergoes the opposite process. So this is the oxidation. Thermodynamics of redox reaction. Redox reactions are either spontaneous or non-spontaneous. The energy associated with the spontaneity of chemical reaction is the Gibbs free energy. So the equation that relates the Gibbs free energy with the electrochemical potential is shown below. So this is the formula. So G cell is equivalent to N F E cell. So where F is 96,485 coulombs per mole, also known as Faraday's constant. Also, the equilibrium constant can be related to the Gibbs energy. So this is the formula. Electrolysis reactions. Electrolysis reactions are redox reactions that result in the splitting of ionic salt to form the gaseous halide and the metal. For sodium chloride, so 2 sodium chloride 2 will be 2 sodium plus chloride 2. So electrolytic reactions are non-spontaneous redox reactions. Therefore, a supply of energy is necessary. The net cell potential for these types of reaction is negative. Nuclear chemistry. So, nucleus. Nucleus of an atom is composed of two subatomic particles, the proton and the neutron. They are bound by the strong and weak nuclear forces. Mass number and atomic number. The mass number is the sum of the number of protons and neutrons. The atomic number is the number of protons in the nucleus. The number of protons determine the identity of nuclei. Elements may have different number of neutrons. These elements are called isotopes. Types of nuclear reaction. There are two types of nuclear reactions. So number one is nuclear transmutation, the radioactive decay, and thermonuclear reactions. This is the nuclear fusion-fission reactions. So nuclear transmutation are processes that result in gradual release of subatomic particles with high energy. There are four types of nuclear transmutation. Number one is alpha particle emission. Alpha decay or A decay is a type of radioactive decay in which an atomic nucleus emits an alpha particle. These are the helium nucleus, and thereby transforms or decays into a different atomic nucleus with mass number that is reduced by 4 and an atomic number that is reduced by 2. Number 2 is beta particle emission. Beta minus particle emission occurs when the ratio of neutrons to protons in the nucleus is too high. An excess neutron transformed into a proton and an electron. The proton stays in the nucleus and the electron is ejected energetically. Number 3 is positron emission. Positron emission or beta plus decay is a subtype of radioactive decay called beta decay, in which a proton inside a radionuclide nucleus is converted into a neutron while releasing a positron and electron neutrino. Number 4, electron capture. Electron capture is a process in which the proton-rich nucleus of an electrically neutral atom absorb an inner atomic electron, usually from the K or L electron shells. This process thereby changes a nuclear proton to a neutron and simultaneously causes the emission of electron neutrino. Thermonuclear reactions are reactions that require a high energy initiation step. These reactions happen at very high rates and releases tremendous amounts of energy. It results either to splitting of nuclei into smaller products, fission, or formation of a large nucleus from smaller nuclei. So we have here number 2, thermonuclear reaction, that is nuclear fusion. Nuclear fusion is a reaction in which two or more atomic nuclei are combined to form one or more different atomic nuclei and subatomic particles. While nuclear fission is a process in nuclear physics in which the nucleus of an atom splits into two or more smaller nuclei as fission products and usually some byproduct particles. Hence, fission is a form of elemental transmutation. Uses of isotopes, radiation, and radioactive. We have the medicine, archaeology, and also we have chemical analysis. Thank you very much.